Hey pioneers, and welcome back. On our last video we started this factory that makes space elevator parts, and it has the extra challenge of doing a lot of load balancing even if we have weird numbers. Only the first stage of the factory is not load balanced. In some cases that was when building the load balancer was not impossible, because it's never impossible, but it meant like dividing a build into 150 equal parts. That's a huge load balancer. Usually if you wanted to have the whole factory load balance, you would play with the design so that you don't have to do those weird divisions. So what I did is I moved all of that crap to the first stage. So the first stage is going to be ugly. Still not with a manifold, with a smart manifold, but after that everything will be load balanced. With that being said, let's dive in. Well, I added a little verticality. Over these load balancers I made a roof, and here we are basically doing our heavy modular frames that we already had most of the materials. Had to craft the encased industrial beams and the modular frames, but most of these materials were already prepared. For example, this load balancer, I'm already using 2 of its outputs, and this concrete load balancer I'm also using the 2 outputs. So I'm kind of trying to use what we have already prepared. Well, there's some stuff. What is this? Steel beams. I don't know what that is for, but it's for something. Now, I did something silly. I wanted to keep this place for the heavy modular frames, but the thing is that I didn't need that much space. So, well, for example, here we have 2 assemblers doing the modular frames, but they are at less than 50%. This could have been done by 1 assembler, and I originally placed 1, but then I said, hey, there's too much space. So, well, now we have 2, and they are load balanced, so we can say that we are saving power. And the same thing is for the encased industrial beam. Originally it was only 1, but there was too much space, so now we have 2, and they are clocked at less than 50%. So, well, let's just pretend that I care about power, and I'm saving power, and I'm a smart pioneer. So, well, I already did this module. There was nothing relevant to mention over here, no load balancing, nothing weird. I did have to place some belts over the roofs. As usual, I placed these frame foundations just to reserve that space. This is not going to end up like that. I will do something a little bit cooler, but I need to know to reserve that place, because then I place a constructor and then my life's a mess. So now we know that I can't place anything right there. And well, let's continue with something. I've been doing this in a very disorganized manner. I don't know what needs to be done, but well, I'll check the diagram and see. Have I placed this? Yes? Okay. No? Let's place it. Well, I made a mistake on our last video. I was trying to continue with the factory and I couldn't find a refinery. Turns out I've miscounted them and I needed 1 extra refinery to do copper ingots. So, well, I had to mass dismantle this whole side, and now we can see that we have 5 over here and we have 6 over here. That wasn't fun, but well, it's made, and we barely made it with space over there, but that's considered acceptable, so it's all good. Now, all of that part is the same, and I added this little tower. Here we are doing the reinforced iron plates. Now, one thing I asked myself is, well, what if instead of adding 1 refinery, because I was missing 1 of these, I simply merge both of them and then load balance this division? So I made the math, and that ended up meaning that I had to divide the build into 173 equal parts, send 45 to one side and 128 to the other. So yeah, that was a huge load balancer. I was not going to do that. But it's cool to know that it doesn't matter the decimals, it's always possible to load balance. But well, you have to be insane to do a load balancer that size. So what do we have here? This first stage is doing the wire. We have weird numbers. top stage is doing the iron plates, and in the middle we are doing our reinforced iron plates. So yeah, it ended up working. But that was a huge load balancer I wasn't doing. So yeah, we, as always, the first stage, this one over here, works via priorities. But after that, from then onwards, everything will be load balanced. Now let's continue. And we've got our first space elevator parts. I added this segment over here. So we start by doing some steel pipes, connecting the last refinery that was doing concrete. These steel pipes are turned into modular frames, taking the reinforced iron plates from this tower. And then these modular frames are turned into versatile framework, which needs steel beams, that it would be this fancy connection over here that I made it go through one of these frame foundations, and the foundry was that one. So these versatile frameworks, we need part of it for another space elevator, but I was also taking some of the output because I hadn't automated it. So that would be this tiny load balancer. We need two-thirds to continue to work on, and the other third will go to our space elevator. So these two-thirds go over here to do our magnetic field generators. That also need electromagnetic control rods that we had already prepared those on our last video. And now the output of the magnetic field generator, I am merging it with this third of the versatile frameworks, and we will be doing a sushi line with all of our outputs. That I won't even have to separate that sushi line, because we need to send that to the middle tower of that factory, which has a drone that accepts a sushi line and sends it to the space elevator building, and there all of the logistics are already done. Each material will be separated and either sent to a dimensional depot or sent to the actual space elevator. And then we also had, here we were separating the electromagnetic control rods, because this is another material that I hadn't automated, and it's the only output that we are currently doing that doesn't need to be sent to the space elevator. So I just took it this way to industrial storage container and dimensional depot with a smart splitter that sends the overflow to the sink. That's going to be a sad sink because it's barely going to end up receiving 3.5, so it's not really going to do much work. But well, we have two space elevator parts. We are still missing one, I think, and I don't know how many machines. I'm kind of lost, but let's just continue placing stuff. Good news, we are actually pretty close to finishing this project. Well, finishing placing the machines. There's still a lot of work to be done. So I came back to this segment we made on our last video that produces the circuit boards, and over here we have a weird split. So what's going on? We are producing 13 per minute, and we need to send 8 to one place and 5 to another place. So doing the math in this case is quite straightforward. 13 divided into 8 and 5, we need to send 8/13ths one side and 5 to the other. So how are we going to do this? Here we have another high-tech diagram. And if our belt, we divide it into 2, then we divide it into 2 again, we divide it into 2 again, and we divide it into 2. Each one of these is our belt divided by 16. But this is our base. We will do some modifications. So, for example, if I erase all of this and I send this belt right over there. Now, these ones over here will no longer be our belt divided by 16, it will be our belt divided by 14. But that's still not the number we want. So we will be taking one belt from here, and we will send this again back to our initial merger. So now we end up having 13 belts. And that's the denominator we were looking for. So from these 13, we needed to group 5 to one place and 8 to the other. That means that one of our outputs will be these 5 belts, which means that we don't have to place neither this splitter, nor this splitter, nor this splitter, and our other output will be these 8 belts. Oops. Which means that we don't have to place none of these splitters. So it starts scary, but then when you start grouping them up, you end up having less stuff. It would be 1 merger and 4 splitters, or maybe something else, I don't know. When I build it, I'll realize. So that's the plan. Let's go and build it. And that gives us this cute little load balancer. I love how it ended up looking. It's all just a big line, and these are the 2 feedback loops. But does it work? There's only one way to find out. So we will drop exactly 13 circuit boards and see if we get 8 and 5. So now we have to wait. And the last circuit board arrived. Moment of truth. We've got 8 this side and 5 this one. So this load balancer works. We've got a perfect split. Now let's plop the final machines and get this over with. And these are the last 3 machines I was missing. Over here we have manufacturers doing computers that go over here that do adaptive control units that finally go to this assembler that does the assembly director system. Supercomputers, we are not crafting them here because I am already creating 10, so this would be an input to the factory. That of course it won't be load balanced, but who cares? This will be saturated. Now, I was having a lot of trouble setting up all of the belts because there's a lot of stuff you need to connect. And then I realized something that I should have realized before. There's an advantage of having everything load balanced. That means that there's not a single belt that is going to be saturated, meaning doing sushi belts is extremely easy. So for example, where did we start? Over here. This module is doing 12 stators and it's only sending 6 this way. This was a belt that I had already placed. But if we follow that belt, I placed a merger over here. What is this? These are our 16 cable that come from this load balancer and also 5 automated wiring. I made this small load balancer because we are producing 6 and we need to send 5 to this factory and 1 to the space elevator. So I'm mixing the cable with the automated wiring with the stators that were going this way. And we continue the chain up to there. There's another merger. These are our heavy modular frames. So, super sushi belt, we continue going this way. All the way up to here, where we start separating those materials. So we have the smart splitter taking the stators to that machine. Then we have another one taking the cable for our computers. We have another one taking the heavy modular frames to the adaptive control units. And the last one, this is not, I wouldn't need a smart splitter over here, but well, it's sending the automated wiring to this manufacturer. So I can transmit all of the materials with one belt. There's no need to make a mess. And why do I have 2? Well, because one is going one side and the other one is going the other side. So for example, the output, the assembly director system, is going on the second sushi belt that goes to a merger that is merging, what was this? Our versatile frameworks with our magnetic field generators. And they keep on going this way until we get another merger. This one has reinforced iron plates, so we mix all of them. We continue going this way on the lower belt to a first smart splitter That's going to take out the reinforced iron plates that need to go to that module over there. So we continue going. There's another merger. This merger is merging our last automated wiring, the 1 per minute. And finally, this would be the sushi belt that needs to go to the space elevator. So now I'm wondering if I could have simplified everything. There are more belts I could simplify, but while I won't rebuild everything, I'm loving that only by having 2 belts I'm connecting everything with everything, and that is because as all of the materials are load balanced, that belt will never saturate, so there's no chance of choking. It could choke only at the beginning if one module starts way before the other one, because even though everything is load balanced, the first stage isn't, so we could have some machines starting before the others. But after that, if we survive the beginning, everything will work perfectly non-stop with only 2 belts. So I'm really glad with that. So now that all of the machines have been placed, we need to start handling all of the inputs and all of the power connections. So let's do that. And just like that, we wrap up another factory. Honestly, this one didn't end up taking that much time. And after spending an entire month building skyscrapers, Ada is happy. And so are my poor wrists. Even better, no issues. Everything worked on the first attempt, which hasn't happened in a while. I almost forgot what success felt like. 10 out of 10. Highly recommend. Now let's talk load balancing. I used to be terrified of splitting between weird numbers. I'd try dividing by 2 or 3 a couple of times, and if it didn't land perfectly, my brain would just go, "Welp, guess it's impossible, moving on." But here's the truth. Every single division can be load balanced. Sure, sometimes you end up with a monstrosity of a balancer that's bigger than the factory itself. But hey, technically it can be done. And honestly, I had a blast designing these ones. It wasn't even that hard. It's just a cool brain teaser once you get the hang of it. The biggest advantage? Well, cramming everything onto a single sushi belt is clearly a win. I should have figured out this earlier. I could have been moving so much more stuff around. And after finishing the factory, it hit me. This trick can help even more. You can connect just one input belt to a manufacturer and treat it like a big constructor's. If belts are properly balanced, you can feed everything through a single input. And it should work. Famous last words. I'll definitely be trying that in my next build. Now, what about downsides? Well, miners for one. You usually don't fully use a node's output. And if you ever want to connect a new factory later, good luck. You'll have to tear everything down and redo the whole setup. Yay, manual labor. Or take my giant train station as another example. I'm bringing tons of raw materials from across the world, and each factory usually grabs 5 or 6 different resources. If I load balance that, I'd have to demolish and rebuild the load balancers every single time I add a new factory. Ain't nobody got time for that. Oh, and one last unexpected win. Since I had already everything rolling down a sushi belt, hooking it into my drone port was effortless. Just connected a single belt and boom, all the space elevator parts started flowing automatically. 0 extra effort. And that wraps up today's video. So, what's next? We are almost done with phase 4. We are only missing nuclear pasta. And, well, I might have gotten overexcited. I already designed that factory. It's actually not that hard. It's a small factory. But, well, to be honest, maybe it's not the responsible thing to do. Because we are kind of running short on power. And the idea is doing a huge nuclear plant that you need power to start it. So maybe I should be doing that nuclear plant right now, but I think we'll be moving to phase 5. Which brings some mixed feelings. I'm really excited about new stuff. But on the other hand, phase 5, we are getting closer to finishing the game. What will I do with my life once I'm done? Usually people do several playthroughs, but I don't know, I'm around 800 hours on this one, and I already am playing by very strict world rules, so I don't know if I could find something exciting to start over. So well, I will have to give it some thought. But well, that's all we have for today. I hope you guys enjoyed it. If you did, please just let me know, leave a like, leave a comment. Even if you don't know what to comment, let's discuss something. Do you like board games? And if you do, what board game is your favorite one? I simply love them. I think it's the best thing to do with friends in a gathering or with family. They are usually pretty dope. And if I had to pick one, well, I don't know if it counts as a board game, but I love Magic the Gathering. I know, kind of geek, right? But well, I used to play it a lot with friends. Right now, living in Sydney, I'm all by myself, so I haven't been playing that much. As a matter of fact, each factory name, that might sound weird, they are all inspired in Magic the Gathering lore. So every time I have to pick a name, I just go to that game and choose one from there. So what about you? Do you like board games? Which one do you enjoy the most? I hope you guys enjoyed today's video, and I'll see you on the next one.